So in the next part of the algebra review, we're going to look at basically two different important concepts in algebra. One is some different things involving laws of exponents, also is some different things involving simplifying polynomials, otherwise known as combining like terms. So the first thing we're looking at here are some different laws of exponents involving multiplication. So the key rule to remember when you're talking about laws of exponents involving multiplication is that whenever you have variables that are the same, the key to, or the shortcut to, multiplying is to add the exponents. So for part A here, I have x to the 7th times x. So just keep in mind that x by itself really means x to the first power. So when I'm multiplying two variables that are the same, I want to add the exponents. So to simplify x to the 7th times x to the first, this would be x to the 8th power. So that's part A. For part B, I have the same thing here, although with this one I have two different variables and some coefficients. So I have this negative 3x squared y times 7xy cubed. So with this right here, what I want to do is I want to multiply together the parts that are the same. So first I'm going to start with the coefficients. Negative 3 times 7, that's negative 21. And then I have the x's. So when I got x squared times x, remember that's x to the first, since the variables are the same, the shortcut there is to add the exponents. So x squared times x to the first would be x cubed. And then I'm going to do the same thing with the y's. This is y to the first. So I got y to the first times y cubed. So once again, since the variables are the same, I'm going to add the exponents. So the answer to this would be negative 21 x cubed y to the 4th. And then the same type of thing for the last part here, part C. I got this here. So keep in mind a couple things here. One is whenever there's no number in front of that x there, I'm going to put a 1 in, and this is also x to the first, this is also y to the first. So with part C, I'm going to do the same thing here as I did with part B. I'm going to multiply together the parts that are the same. So first I'm going to start with the coefficients. Negative 5 times negative 1 is positive 5. And then I'm going to multiply the x's together. X squared times x to the first would be x cubed. Once again, add the exponents. And then I have y to the first. And then if you notice, there's no other y to multiply that with here, so that's just going to stay y, or y to the first. And then I have z cubed here at the end. And once again, since there's nothing over here to multiply that with, that's just going to stay the same. So one of the things that I showed you in the first review involving the calculator and checking your answers, I'm going to show you something similar here with laws of exponents, which actually will also work with some different things that I'll show you with combining like terms. So if you take, for instance, part A, x to the 7th times x, if I was going to use my calculator to check my answer to that, what I want to do first is I want to store a number in for x, and I can make x any number that I want. Just try to stay away from storing numbers in for x that are 0 or 1, because what I'm going to show you doesn't always work when you do that. So if I were to say store a 2 in for x, and then I type in what the question says, which in this case was x to the 7th times x, get an answer. And then I'm going to type in what we said the answer was, which was x to the 8th power. And when I do that there, you'll notice that the answers for those are the same. So very similar to what I showed you with square roots involving checking your answers. The only difference here is that because we're talking about variables now, you have to assign the variable a value before you can type in the question, type in the answer, and make sure that the two answers at the end here match each other. So that's one of the laws of exponents that you need to know. Another one has to do with some other things involving multiplication. So whenever you have, and these are referred to as sort of double exponent problems, or sometimes it's referred to as a power of a power, the shortcut for these kind of problems here is to take the two exponents and multiply them together. And I'm going to show you why here in a moment. So I got this here, c squared to the 5th power. So remember that to take something to the 5th power means to multiply it by itself 5 times. So I'm going to do this here. And what this turns into is the problems that we did from example 1. So if you notice here, all the variables are the same. So since they're the same, I can add the exponents. 2 plus 2 plus 2 plus 2 plus 2 would be 10. So this would be c to the 10th power. Well, the shortcut here is whenever you have double exponents, meaning you have parentheses with an exponent on the inside as well as the outside. The shortcut there is just to multiply the two exponents together and call it, in this case, c to the 10th. So for part B, I have this here, negative 4c, and then the whole thing is being cubed. So just keep in mind that the difference between B and A is this whole number in front of the variable piece. So what I want to do is I'm going to take each of these and I'm going to sort of break them apart into two separate pieces here. First I'm going to say negative 4 cubed times, because remember in between the negative 4 and the c here is a multiplication sign, and then I'm going to have c to the first cubed. So negative 4 cubed, I can either do that in my head or do that in the calculator. Negative 4 to the third power, negative 4 cubed is negative 64. And then you can apply that shortcut that we just talked about with the double exponents. 1 times 3 is 3, so this would be c cubed. So that's the answer for part B. For part C, notice I have two variables here. So I have negative x, y squared, and this is the whole thing to the fourth power. So just once again notice there's no number in front of the x, so I'm going to put a 1 in there. So notice with this now I have three parts. I have a negative 1, I have an x, and I have a y squared. And I'm going to take this, I'm going to break it up into three parts. So I got negative 1 to the fourth times x to the first to the fourth times y squared to the fourth. So negative 1 to the fourth, once again, I can either do that in my head or do that in the calculator. That's positive 1. And then I have here the double exponents, x to the first to the fourth. 1 times 4 is 4, so this would be x to the fourth. And then I have, once again, here double exponents. 2 times 4 is 8, so this would be y to the 8th. So once again, I have this 1 right here, but because it's positive, I don't really necessarily need that there. So the answer to this would just be x to the fourth, y to the 8th. And that's the answer for part C. For part D kind of combines what we did from example 1 with some of the different concepts that we just talked about here in this second example. So I have this negative 4x times 5x cubed, and I've got the whole thing here squared. So this part right here is what we did from example 1, and then this part right here is what we were just talking about in the second example. So keep in mind, as far as order of operations go, remember you always want to do parentheses and exponents before you do anything with multiplication. So I actually want to get an answer to this before I do anything with this piece here. So to do that, I'm going to take this, and once again I'm going to break it up into two pieces. I got 5 squared times x cubed squared. So 5 squared, that's 25. X cubed squared, once again, double exponents. I can multiply those. This will be x to the 6th power. So now that I got an answer to this, now I can take this, I can bring it down here. And now this turns into what we talked about from example 1. So keep in mind, this is x to the 1st power. So I'm going to multiply together the parts that are the same. Negative 4 times 25 is negative 100. And then I have x to the 1st times x to the 6th. So once again, the shortcut there, because I'm multiplying, is to add the exponents. 1 plus 6 is 7, so this would be x to the 7th power. And that's the answer for part D. So that's some different things with laws of exponents involving multiplication, or a different type of multiplication type problem. The other thing we're going to look at with properties of exponents has to do with division. So the shortcut when we're talking about division involving properties of exponents is to subtract the exponents. And I'm going to show you here exactly why we do that. So I got here for part A, x to the 8th over x to the 5th. So what I'm going to do first is I'm going to take this and I'm going to break it out, and I'm going to rewrite the numerator and denominator as if it didn't have exponents. So x to the 8th would just be x times itself 8 times. And you'll see why the subtracting for this is much easier than doing it this way. And then x to the 5th, I have this on the bottom, like that there. And what we know is true when we're simplifying variables involving fractions is that anytime you have a variable that's the same on the top and bottom of the fractions, they cancel each other out. So I can cancel these out, these ones here, and these ones here. So I'm done canceling because now there's no more x's on the bottom to cancel out with. So what I'm left with here is the answer. So on the top, I got this, x times x, which would be x cubed. And then on the bottom, if you notice here, everything canceled out. But keep in mind that there is always a 1 in front of this x, just as if there's a 1 here. So this would really be x cubed over 1. So anytime you have a situation where you're canceling or subtracting and everything cancels out on the top or bottom, you want to put a 1 in its place, and then anything divided by 1 is just itself. So you end up with an answer of x cubed for that there. Well, the shortcut for this would be to simply just take the exponents, because the variables are the same, and subtract them. So I have this here, right? So I would say 8 minus 5 is 3, so the answer to this would be x cubed. Now what's important here is when you subtract the exponents, two things. One is that you always do bigger minus smaller, and then your answer always goes on the side of the fraction that has the bigger exponent. So since 8 is bigger than 5, that means my answer to this would go on the top of the fraction, which would technically still be over 1, but then anything divided by 1 is just itself. So that's just some different things there, some basics involving laws of exponents with subtraction. For part B, I'm going to do the same thing. I got negative 15a squared b cubed over 5ab to the fifth. So a couple different things here. One is the coefficients. So before you do anything with the variables, always simplify the coefficients first. So I'm going to reduce negative 15 over 5. That's going to be negative 3 over 1. So I'm going to have that there. Then I'm going to take a look at the exponents, and I'm going to group them by exponents that are the same, and I'm going to subtract bigger minus smaller. So in this case I got a, or a to the first, on the bottom. So when I go to do this, the answer to this, 2 minus 1 is 1. The answer to this would be a to the first, and my answer goes on the top because the exponent on the top is bigger than the one on the bottom. And then I'm going to go to do the b's, and the answer to this, 5 minus 3 is 2, so the answer to this would be b squared. However, for this one, my answer is going to go on the bottom because the exponent on the bottom here is bigger than the one that's on the top. So the answer to this would be negative 3a over 1b squared, or you could say negative 3 over, once again, we don't need that 1, we could say negative 3 over b squared. And that's the answer for part B. For part C, I have 18 x cubed y to the fourth z to the first over 27 x cubed y squared z to the fifth. So when I go to reduce, once again, first I want to reduce 18 over 27. So 18 over 27, 9 goes into both of those. So that reduces to 2/3. Then I have this, the x's, x cubed over x cubed. Well, 3 minus 3 is 0. So whenever you have two variables that are the same on the top and bottom, where the exponents, when you subtract them, equal 0, what we say is those two variables just cancel each other out, and I won't have any kind of x written as a part of my answer. So now I'm going to move on to the y's. So I have y to the fourth over y squared. Well, 4 minus 2 is 2, so the answer to this is y squared, and that answer goes on the top because there's more y's on the top than there is on the bottom. And then I have here the same thing that happened with the x's. If you notice here with the z's, this is z over z to the fifth, so once again I got to put a 1 in here. Okay, so when I go to do this, 5 minus 1 is 4, so this would be z to the fourth, and my answer for this will go on the bottom because there's more z's on the bottom than there is on the top. So the answer to this would be 2y squared over 3z to the fourth. And that's the answer for part C there. For part D, a little bit different in that I have a little bit of some things that I need to work out in the numerator first before I can do anything with simplifying and canceling. So I have this on the top, and then I have this on the bottom. So before I can get to anything with reducing or canceling or subtracting exponents, I have to get an answer to this first, okay, before I can do that. So I'm going to take this, and I'm just going to kind of put this sort of off to the side here. So to square the whole thing means to take each of these three parts to the second power, just like we talked about in the previous example. So this is going to be 3 squared times x to the fifth squared times y to the first squared. So when I go to do that, 3 squared is 9. X to the fifth squared, double exponents, I can multiply those. This would be x to the 10th. And then y squared, y to the first squared, once again double exponents, I can multiply those. This would be y squared. So that's what's going to go on the top here. So I got 9 x to the 10th y squared over 6 x to the 4th y cubed. So first thing I want to do here is I want to reduce 9 over 6. So since 3 goes into both of those, this is going to reduce to 3 over 2. Now I'm going to move on to the x's. So x to the 4th over x to the 10th, the answer to this, 10 minus 4 is 6. So the answer to that would be x to the 6th, and that goes on the top because there's more x's on the top than there is on the bottom. And then I have this, y cubed over y squared, so 3 minus 2 is 1, so the answer to this would be y to the 1st, and the answer for that goes on the bottom because there's more y's on the bottom than there is on the top. So the answer to this would be 3x to the 6th over 2y. So that's some different things involving subtracting with division and exponents. So the other thing we're going to look at with laws of exponents has to do with what happens when an exponent is negative. So whenever you have an exponent, a variable that's taken to a negative power, what that basically does to the variable is it takes the variable and it flips it to the other side of the fraction. So for instance, with this here, I have 2x to the negative 2 over 3. So because this variable is to a negative power, what that tells me is I need to take that variable and that exponent and I need to flip it to the other side of the fraction. Now the 2/3 stays 2/3. Nothing with the negative exponent impacts the coefficients. However, this x to the negative 2, I'm going to put that on the bottom of the fraction, and when I switch the side of the fraction, I also switch the sign of the exponent. So 2x to the negative 2 over 3 really becomes 2 over 3x squared. So that was part A there. So for part B, same kind of thing. I got 3x to the negative 2 over 9y to the negative 3. So notice here I do have coefficients that can be reduced. 3 over 9 is going to reduce to 1/3. So I'm going to do that first. Then I'm going to take each variable and decide if I need to flip it to the other side of the fraction or not. So because this is to a negative power, I got to flip that to the other side of the fraction, and when I do that, the 2 becomes positive. Same thing here with y to the negative 3. Because it's a negative power, I'm going to move it to the top of the fraction, and when I do that, the exponent becomes positive. So this is 1y cubed, or just y cubed, over 3x squared. That's the answer for part B. For part C, I have 4x to the negative 3. Try that again. Over 8x to the negative 5. So same sort of thing here. I want to reduce the coefficients first. 4 over 8, that reduces to 1/2. And then I'm going to take each of these and I'm going to flip them, because they're both to a negative power. I'm going to flip them to the other side of the fraction. So it ends up looking like this. But if you notice with this, and this is a little bit different than parts A and B, I end up with variables that are the same on the top and bottom. So there's some canceling that I can do there with subtracting the exponent. So 1/2 will still stay 1/2. However, x to the 5th over x squared, when I do 5 minus 3, the answer to that's 2. So the answer to that's x squared, and the answer will go on the top there because there's more x's on the top than there is on the bottom. And that's the answer for part C. For part D, sort of clear these out, I have negative 2 x squared y to the negative 3 over 4 x to the negative 3 y to the negative 4. So a lot of different things I got to do here. First is I have to reduce negative 2 over 4. That's going to reduce to negative 1 over 2. Then I have this x squared. Now notice that exponent's positive, so it stays where it is. That stays on the top. However, x to the negative 3, because that's a negative power, that's got to get flipped. And when I do that, that becomes positive 3. Y to the negative 3, negative power, that's got to get flipped to the bottom. Y to the negative 4, once again, negative power, that's got to get flipped to the top. So a couple different things that I can do here to simplify this. One is negative 1 over 2, that's going to stay the same. But I can combine x squared times x cubed. So remember, there's a multiplication sign there, and the shortcut for multiplying is to add the exponents. So that ends up being x to the 5th. And then here, y to the 4th over y cubed, I can subtract the exponents because it's division, The answer to that ends up being y, or y to the first, and that answer goes on the top because there's more y's on the top than there is on the bottom. And that's the answer for part D there. For part E, notice here I have just some straight multiplication that I'm doing. So remember, when you're multiplying, the shortcut is simply to just add the exponents. So when I have x to the negative 8 times x to the 10th, negative 8 plus 10 is positive 2. So you end up with that there. And then y to the negative 5 times y to the negative 2 would be y to the negative 7. So since that's a negative power, what I want to do is I want to take that and I want to flip it to the bottom of the fraction, and the answer to this ends up being x squared over x to the 7th. So you have something like that there for part E. And then for part F, notice I have the whole thing here taken to the negative 2 power. So what I want to do first with this, and there's a lot of different ways that we can go about sort of answering this. So what I'm going to do first is I'm going to take this negative 2 and I'm going to take it to the top and bottom. So I'm going to turn this into a problem that looks very similar to what we did in example 2. So I have this first, 6a squared b cubed to the negative 2 over negative 2a to the first b to the negative 4 to the negative 2 power. And what I'm going to do is first I'm going to simplify this. So I have 6 to the negative 2. So just keep in mind that when I have, let me just sort of write this out here. So I got 6 to the negative 2 and then I have a squared to the negative 2, and then I have b to this b cubed to the negative 2, and then on the bottom here I have negative 2 to the negative 2, a to the first to the negative 2, b to the negative 4 to the negative 2. So all these negative powers, what I want to do here is I want to basically take them all and flip them. So all of these negative powers on the top, I'm going to put them on the bottom and make them positive. So I'm going to sort of put this over here. So this ends up being 6 squared over a squared squared, and then b cubed squared. And then I'm going to take all these negative powers and I'm going to put them on the top. So I have negative 2 squared, and then I have a to the first squared, and then I have here at the end b to the negative 4 squared. So when I work all this out, negative 2 squared is 4, a to the first squared is a squared, b to the negative 4 squared is b to the negative 8, and then on the bottom I have 6 squared is 36, a squared squared is a to the 4th, and then b cubed squared would be b to the 6th. So when I simplify this, 4 over 36, that reduces to 1 over 9, and then I have here a squared over a to the 4th. 4 minus 2 is 2, so the answer to this is a squared. That's going to go on the bottom. And then this b to the negative 8, I got to drop that to the bottom and make it positive 8. And I can put b to the 6th and b to the 8th together. This would be b to the, I'm running out of room here, b to the 14th power. So the answer to this would be 1 over 9a squared b to the 14th power. And that's just some different things that we're looking at involving exponent properties. Some other things that are going to kind of tie in with this in terms of what we're going to do with this in class has to do with some different things involving simplifying polynomials. So if we're talking about adding and subtracting, remember that you can only add and subtract terms with variables if the variable and exponent are both the same. And if they are, the rule is you add the coefficients and you keep the base the same. So for instance, when I do 2x plus 5x, the answer to this would be 7x. 2x minus 5x, because they're both x's, the answer to this would be negative 3x. So when I do 2x squared plus 5x squared, because the variables and exponents are the same, I can add the coefficients, but the base stays the same. So that would be 7x squared. Same thing here, because the variables and exponents are the same, I can subtract the coefficients. So this would be negative 3x squared. However, with part E, when I go to do 8x to the 4th plus 9x to the 5th, because with this, even though the variables are the same, however, the exponents are different. So because the exponents are different, these are not like terms, so I cannot add these together. So the answer to this is simply just the question, 8x to the 4th plus 9x to the 5th. So that's the answer for part E. And that's just some different things involving addition and subtraction. With multiplication, which is what we kind of just talked about with some of the different laws, 2x times 5x, 2 times 5 is 10, x times x is x squared. When I have for part G, 2x squared times 5x squared, once again 2 times 5 is 10, x squared times x squared, the shortcut there because I'm multiplying is simply to just add the exponents. For part H, 2x times 5x squared, 2 times 5 is 10, x times x squared, remember that's x to the first, so 1 plus 2 is 3, so this would be x cubed. And then I have 2x to the 4th times 4x to the 4th, 2 times 4 is 8, x cubed times x to the 4th, once again I'm going to add the exponents, so that would be x to the 7th. So just note here that even now with the multiplication side of this, even though the exponents were different, I can still multiply those together. However, when you're talking about adding or subtracting, the variables and the exponents both have to be exactly the same. Some other things with simplifying has to do with just some different things involving straight combining like terms. So for instance, with 11x minus 5x, because the variables are the same, I can subtract the coefficients. 11 minus 5 is 6, so this would be 6x. With part B, just notice I have some distributing that I need to do first before I can combine like terms. So when I distribute the 2 to the parentheses here, this ends up being 2y plus 10. And when I distribute the negative 3 here, this ends up being negative 3y plus 27. Just notice it's plus because you got a negative 3 times negative 9. Now that there's no parentheses, now I can combine like terms. 2y and negative 3y would be negative 1y or just negative y. And then 10 and 27, that would be positive 37. So with something like that for part B. For part C, just notice here that I have two different variables. So just keep in mind that you can only put together terms that have the same variable. So with part C here, I can put the x's together. 14x and 5x would be 19x. And then I can put the y's together. Negative 6y and 13y would be positive 7y. So you end up with something like that there. So one of the things just to show you with this involving checking your answers on the calculator. So once again, since we're talking about variables, I need to store a number in for x. So with the previous example that I showed you with checking this on the calculator, I stored a 2 in for x. Let me pick a different number this time. So I'm going to put a 3 in for x. So to check part A, what I would want to do here is I would want to type in first the question, 11x minus 5x, get an answer, and then type in what we said the answer was, which in this case was 6x, and just make sure those answers at the end match. So similar to what we did before, in that you have to put a number in for x first, you have to assign x a value, and then once you do that, you can type in the question, type in the answer, and then just make sure the answers that you get at the end here are in fact the same. So that's some different things you do with checking your answers to those kind of problems on the calculator. So for example 3, we're talking about taking the terms of one set of parentheses, and in this case for part A, we're going to add them to the like terms in the second set of parentheses. So keep in mind that you can only add together terms that have the same variable and the same exponent. So I'm going to do this in descending order, which descending order means I'm going to write my answer in order from highest power to lowest power. So with this here, I'm going to start with the y cubed since that's the highest power. And if you notice with this, there's no other y cubes over here to add to this. So 2y cubed is just going to stay 2y cubed. Nothing changes there. Now I'm going to move on to the y squared. So I have negative 7y squared. I'm going to add that to negative 4y squared, which would be negative 11y squared. Then I'm going to do the y's. So here I got negative 6y, and I'm going to add that to positive 3y, which would be negative 3y. And then this minus 9 at the end, there's nothing to combine that with, so minus 9 just stays minus 9. And that's the answer for part A. For part B, I'm going to do the same thing, but in this case, instead of adding, notice I'm going to subtract the like terms in each of the parentheses here. So first I'm going to start with the x squared. So I have 8x squared, so I'm going to do 8x squared minus 12x squared. That's going to be negative 4x squared. So that takes care of those terms. Then I'm going to do the x's, negative 5x minus negative 9x. Remember, when you're subtracting by a negative, that really means to add. This ends up being positive 4x. So that gets rid of those terms. And then I have at the end here positive 11 minus positive 3. Once again, subtracting by a negative is the same as adding. So this ends up being plus 14 at the end. And that's the answer for part B there. Some other things that we do with combining like terms has to do with foiling, and this kind of sets the stage for what the next review is going to be, which involves factoring. So whenever you're foiling, what you're basically doing is taking the terms from one set of parentheses and you're multiplying them to the terms in the other set of parentheses. So when I do x plus 3 times x minus 4, what I want to do first is I want to do x times both of these terms. So it's almost as if like you're ignoring the plus 3 in the beginning here. So x times x is x squared, x times negative 4 is negative 4x. Then I'm going to do the same thing I just did with the x, I'm going to do the same thing with the positive 3. I'm going to multiply positive 3 to both terms in the second set of parentheses. So positive 3 times x is positive 3x, positive 3 times negative 4 is negative 12. So that's what you get when you do the foiling or do the distributing. Now I just want to combine like terms. So if you notice, the only like terms here are the two terms that are in the middle. So x squared stays x squared, negative 4x and positive 3x becomes negative 1x or just negative x, and then minus 12 just stays minus 12. And that's the answer there for part A. For part B, I have the same thing here. I'm going to multiply 3x to both terms in the parentheses here. So when I do 3x times 4x, that's 12x squared. And then I have 3x times positive 7, that's positive 21x. And then I'm going to do the same thing with the positive 2. I'm going to multiply it to both terms in the second set of parentheses. 2 times 4x is 8x. And then 2 times 7 would be positive 14. Now, once again, I'm going to combine like terms. So 12x squared stays 12x squared. 21x plus 8x would be plus 29x. And then plus 14 would just stay plus 14. So that's the answer for part B. For part C, I have 5x minus 2 times x plus 3. So once again, I'm going to distribute the 5x here first. So when I do 5x times x, that's 5x squared. 5x times positive 3 is positive 15x. Then I'm going to do the same thing with the negative 2. I'm going to distribute that to both terms in the second set of parentheses. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Then I'm going to combine like terms. So here I'd have 5x squared plus 13x minus 6 at the end. And that's the answer for part C there. So that's just some different things that we do with some algebra involving combining like terms, as well as some different things with laws of exponents. In the next review, what we're going to look at is some different things involving factoring.